Hello, my name is Ishan Mehta, and today I'm just going to be walking you through my CS109 Fall Extra Credit project. So first up here, I have an Excel sheet that I've created, and it's a very simple sheet. On the left, I've just kind of listed out the teams grouped up or divided by their groups, and then I have their FIFA rankings as pulled from the websites listed in my sources of my written document. FIFA ranking in group is just a basic calculation of 1 minus your ranking divided by the summation of the rankings in your group, essentially a measure to measure group difficulty. FIFA points, also from an online source, which is cited. Qualifying wins, draws, losses, goal differentials, and matches, all from ESPN. And then that comes to a qualifying score, which has been derived by this formula right here, basically dividing each one by its respective thing at correct ratios. That gives me an ELO rating for each team. And then I'm eventually going to take this ELO rating and plug it into my code. So let's take a look at that. So here is my code. It's pretty simple. So up here at the top, I have a few dictionaries, win probabilities and points. Group stage dictionaries are just dictionaries in which the entire entry is the games being played. So the first game of the World Cup was Qatar versus Ecuador. Second was England, Iran, then Senegal, Netherlands, so on and so forth. And the way that it works is the first team isn't necessarily the home team, but the first team is the way that I calculate the ELO rating. So that's why it's a little important which team goes first. So I have my group stages set up, and then I have my list just divided by groups again, and then just setting up a few lists here so it's easy to for loop through later. So I'm actually just going to go to main, and I'll kind of scroll back up to these functions as I need them. So first thing I do is just ask, there's basically two options that my thing will allow, and that's either for one team or for multiple teams. So let's actually run this right now. And so what's going to happen is it's going to ask me, oh, what team do I want to get? So let's say I choose like Brazil, for example, or actually, sorry, that example is already up. Let's do like Belgium, right? So we're going to let that run for a second while I continue to talk about this. So now we're going to run this in N simulations, which has been listed as 400 at the beginning here. What it's going to do is going to load in this points dictionary, load in the data from the Excel file, 109 final.tsv. And then it's going to populate the dictionary, which is really just putting everything into a dictionary, loop through all the group stages. And here we're going to kind of do this compare ELOs function, which is a very interesting function. And what that's going to essentially do is this is kind of the most probability that happens. It's going to have a variance. It's going to have the stats.norm, and this variance is calculated through online sources, also cited. And it's essentially going to return which team is more likely to win. And then that's going to go into a single game function, which is then going to use the probability calculated above and do a Bernoulli on it, deciding whether it should be a win for team one, a draw if the probabilities are too close, or a win for team two. So that's kind of how all this goes. And then finally, we're going to call this thing called change ELOs. And what change ELOs does is it's more of like a probability confidence type of situation, in the sense that it will go ahead and tell me, hey, this is, your ELO rating going to be changed if you're the expected winner and you win, expected loser and you lose, and vice versa. So just kind of tinkering with the ratings to make it more like conditional probability based. Real quick, we can direct our attention down here to saying Belgium has a 25.25% chance of winning. And I'm actually going to run this one more time, and this time I'm going to print all the teams out. So let's give that a second to run as we continue here. So basically, once we go through the group stage, it's pretty simple. We're just going to go ahead and create ordered, which is for all the teams who advance to the round of 16. And we're going to do the same thing. And then we're going to create quarter list and do it again for the quarterfinals, do it again for the semifinals, do it again for the finals. Nothing really changing, so just using compare ELOs. The only difference in these functions is I'm using something called single game playoffs, which is slightly different from single game in the sense that single game allows for the draw possibility and single game playoffs does not. It's just a straight calculation on the Bernoulli, which makes sense because you cannot draw in the playoffs. Once I come through that, I'm just going to add one to that win probability dictionary of whoever ended up winning the entire simulation. And then if the user asks for all, I will just go ahead and print everything out as far as probabilities. And if the user just wanted a specific team, as you saw with the Belgium example, then I would just print out the probability for Belgium. So that's kind of how we got this 25.25% chance over 400 trials. So we're just going to let this all kind of finish out its run here. There it is. That was good timing. So we see like Netherlands has a 4% chance, Senegal a 1% chance, United States a 0.025, England probably the highest at 37, Belgium at 16.5, Croatia, Brazil. So you can kind of see like some of the best teams right here: Brazil, England, Belgium, good chances, right? Whereas teams that don't really have a great chance but could possibly happen, teams like Portugal, possibly Mexico, the United States, Senegal. So it seems to be a very accurate representation as far as the strength of the teams. Like, I would never predict that a team like Qatar has a chance to win the World Cup. Now, of course, this is only based on 400 simulations. If I was to go ahead and throw this into, say, 50,000, I'm sure that every team would be much higher than zero. It's just a matter of, the run power of the computer not really being able to support that. But I have run it with 2,000, 3,000 simulations before, and the probabilities all kind of tend to hollow out to the point that no one caps over 30%. So this England number could be a little bit high. But yeah, that's pretty much my project. You can kind of, you saw it with the one team where I used Belgium, and then you saw it with the multiple teams where I kind of just printed it out for everybody. And yeah, this is my code. Earlier I kind of showed my Excel file. So I hope you guys like this project, and thank you for listening. Bye.